Hello, algebra people. Here is your video on writing the equation of a parabola. Now, we've just spent a couple months doing all kinds of different things with parabolas, and we just finished talking about complex numbers. The last thing we're going to do before we move on to polynomials is do three multi-step problems dealing with parabolas and modeling with parabolas. And in those problems, you're going to have to write the equation of the parabola given information. So this video is going to show you two different methods in order to find the equation of a parabola when you're given information. The main methods that we're going to use involve standard form and vertex form. So for type 1, what we're going to do is we're going to write the equation of a parabola if we are given the vertex and another point on the parabola. So if you picture a parabola here, and if we're given the vertex, which remember we called HK, and we're given some other random point on the parabola XY, we're going to find the equation. And what you need to remember is that in vertex form here, now we have to use vertex form because vertex form is the only one that deals with the vertex HK. This one has no vertex in the equation, and this one only has the x-intercepts, no vertex. So if you're given the vertex, use vertex form. Remember, x minus h is the horizontal shift. K is the vertical shift. And A is your leading coefficient. And remember that leading coefficient tells us two pieces of information. If A ends up being positive, our parabola points up. If A ends up being negative, our parabola points down. And it also tells us the narrow or wide. So if A ended up being less than 1, we have a wide parabola. And if A ended up being greater than 1, we have a narrow parabola, like that. When we do an example like this, one thing to keep in mind is we're going to have to find A first. So in every vertex form, you have to get the value of A, and if there is no value of A in front, remember that meant that A was 1, and if A was 1, that meant there was no change in the shape of our parent parabola x squared right here. That meant you didn't stretch it or shrink it at all, you just took it and moved it around left, right, up, or down. So the first thing we'll do is get A, and then we're going to use A to write the final form of our equation. So here's our first example here. We're going to find the equation of a parabola with a vertex of 2, 6 and a point of negative 2, 14. Now picture your vertex being at, let's say that's 2, 6, and let's say that's negative 2, let's call that 14 right here. Now if this is my vertex, and this is my point, and this is going to be reflected over the axis of symmetry here, I'm going to anticipate an A value that's greater than 0. If you want to check if you're right, a good idea is to just really quickly do a sketch of your vertex and the extra point and see if your A value makes sense. Like, is it a positive number, negative? Is it bigger than 1, less than 1, etc. So we're going to take our vertex form here, and we're going to plug in the information that we're given. Now this is the vertex, so this is going to be your HK automatically. Here's your extra point, XY. So we're just going to plug in everything that's given here. We're not going to plug in A because remember we're trying to find A. And we end up with this here. And now really you're just simplifying and solving for A. Simplifying on the inside and squaring gives you 14 equals 16A plus 6. And then I keep solving to get A alone. And A ends up being 1/2. I'm just going to leave it as a fraction for now. And that's actually all the work you really have to do. So now I'm going to go back to here. You never plug in for x or y in your final because you need x and y to have an equation. So minus h squared plus k. And there's your final equation. So these aren't too bad. Once you have A, the only thing you have to remember is to plug in your hk and your A values. And you have your final equation. And as you can see, our A value is greater than 0. Our A value is less than 1, which means that this parabola ends up being a little bit wider than our normal parent function, which might look something like this. My scale is not accurate, which is why it might not reflect that perfectly. Here's the next example, and I want you to try this one here. So I'm giving you a vertex, negative 4, negative 1. I'm giving you an ordered pair, negative 1, negative 28. And if you want, you can plot the points quick and predict what kind of value A should be. So at this point, go ahead and pause the video and give this one a try. And then when we're in class together, we'll compare in your groups. All right, so here's the next type of equation that you're going to be able to write. This is whenever you're given 3 points on a parabola, and for this method to work, one of those points needs to be the y-intercept. So this time we cannot use the vertex form like we did the last time because we don't necessarily know the vertex. It could be that one of these 3 points is the vertex, but we don't know that ahead of time. So what we're going to use is the form of an equation that has the y-intercept in it, which is standard form. And remember that c value here is going to be the y-intercept. So I'll do one with you here, and then I'll have you try one. So we're going to do one with the parabola points 0, 9, negative 2, 25, and 3, 15. So our general method is we're going to take the y-intercept, pause the video to make sure you have this stuff written down because I'm going to scroll up. So again, the general method is we're going to plug in our y-intercept for our c value, and we're going to take each of these points and make a linear equation. And once we have 2 linear equations, then you'll see what we can do with that. So I'm going to take this here, and I'm going to write it over 2 times. First with the point negative 2, 25, and then with the point 3, 15. So remember, these are our x, y values. For y here, I'm going to put in 25. I don't know a. I'm trying to find a. The x value that goes there is negative 2. I don't know b. I'm trying to find b. Bx. And then for c, well, I know what c is. That's the y-intercept. So all my x's went where my x's went. All right, let's write another one for 315. This time 15 is my y equals a x squared plus b x plus c, and the y-intercept doesn't change. It's still going to be the y-intercept here. And again, all the x values went where x goes. So let's clean these up a little bit and rewrite it. So I have 25 equals 4a minus 2b plus 9. And then 15 equals 9a plus 3b plus 9. Now these aren't quadratic anymore. The x squared I plugged in for x, so now these are just linear equations. I have 2 unknowns. That's kind of like the x and y, and I have 2 of them. So if I have 2 variables with 2 unknowns, that's a system, and we know how to solve systems. Before I actually go ahead and solve the system, let's write it so that our variables are on one side and all the constants are together on the other side. So on this one, I'm going to subtract 9. So 4a minus 2b, those can stay together, and then 25 minus 9 is going to give me 16. And for the second one, 9a plus 3b can stay together, and I'm going to subtract 9, and I'm going to get 6. Ooh, just 6. Now you could do substitution, I guess, but this one is already set up so perfectly for elimination that I'm just going to go ahead with elimination. And I'm going to try and eliminate my b value here because they're smaller numbers than the a values. So I'll multiply this one by a factor of 3, multiply this one by a factor of 2. So I multiplied those and I ended up with a new, just slightly modified system. And if I'm going to eliminate my b values, I better be adding these two. So 12a and 18a will give me 30a. These cancel. 48 and 12 give me 60, so that means a is 2. So there's my first a value. I can check that guy off. Now I'm going to go ahead and need to find b. So let's take this equation right here and use it to find b. So I have 9a plus 3b equals 6. Well, I know what a is. And I can go ahead and isolate it. Subtract 18 from each side, so 3b will be negative 12. Divide by 3. b is negative 4. Check. And, well, they gave me c. So my final equation is a x squared plus b x plus c. So this is a parabola that faces up. It's a little bit narrower because a is bigger than 1 with a y-intercept of 9. So I'm going to give you one to try here. Oops. And for this one, this will be your example 2 for this type. I want you to do one where you have the points 0, negative 7, 3, 2, and negative 3, negative 10. So go ahead and get the equation for this here. Make sure you pause the video, or the video is basically done now. So whenever you're done with the video, try this one, and we will compare our answers in class. See you later.